I hope you all are doing well. Today we are going to learn about performance of network, the measure of service quality of a network and the factors affecting the network performance. So let's begin. The examination and review of collective network information to describe the quality of services delivered delivered by the underlying computer network is known as network performance. It is a qualitative and quantitative procedure that assesses and defines a network's performance level. Thus, it assists a network administrator in reviewing, evaluating, and improving network services. So, basically, the network performance is nothing but the quality of information or data we are transferring, and the speed, and how much time it takes for the data to transfer from sender to receiver. The parameters used to measure network performance are bandwidth, throughput, latency, packet loss, and jitter. The quantity of bandwidth allocated to the network is one of the most important conditions of a website's performance. The web server's bandwidth controls how quickly it can transfer the requested data. While there are many elements to consider regarding a site's speed, bandwidth is frequently the limiting issue. The amount of data or information that can be transmitted in a given amount of time is referred to as bandwidth. The phrase can be applied in two ways, each having its own set of estimating values. The bandwidth of digital devices is measured in bits per second or bytes per second. The bandwidth of analog devices is measured in cycles per second or hertz. Okay. So now we see another term, that is throughput. The number of messages successfully delivered per unit time is referred to as throughput. Throughput is influenced by the available bandwidth as well as the available signal to noise ratio and device limitations. To separate the concepts of throughput and latency, throughput will be calculated from the arrival of the first bit of data reaching the receiver for this article. The terms throughput and bandwidth are frequently interchanged in discussions of this nature. The time window refers to the time frame in which the throughput is calculated. The selection of a suitable time window will frequently determine whether or not latency affects throughput. Likewise, whether or not latency is taken into account will determine whether or not latency impacts throughput. Through, so basically, throughput is nothing but the amount of data that is able to travel through your bandwidth given the external factors. Next, we will see latency. Latency is simply the time it takes for data to travel from one designated location to another regarding network performance evaluation. The term delay is sometimes used to describe this attribute. The latency of a network should be as low as possible. Speed of light is the fundamental factor for latency, but packet queuing and refractive index of fiber optic cable are also two factors that can be used to reduce latency. Some of the causes for latency can be insufficient bandwidth, signal interference, distance between sender and receiver, network congestion, and outdated equipment. Okay, now we will see packet loss. Packet loss refers to the number of packets that fail to transfer from one destination to another regarding network performance measurement. This statistic can be measured by recording traffic data on both ends and then identifying lost packets and packet retransmission. Network congestion, router performance, and software difficulties, among other things, can cause packet loss. Now we will see jitter. The variance in time delay for data packets carried over a network is known as jitter. This variable denotes an interruption in data packet sequencing that has been identified. Jitter and latency are linked because jitter generates increased or uneven latency between data packets, which can damage network performance and cause packet loss and congestion. While some jitter is to be expected and can typically be tolerated, quantifying network jitter is an integral part of measuring overall network performance. Here are some factors affecting network performance: network infrastructure, applications used in the network, network issues, and network security. In network infrastructure, that network hardware such as routers, switches, and cables, networking software, security, and operating systems, and network services such as IP addressing and wireless protocols are all part of the entire network infrastructure. Therefore, it is critical to characterize the network's overall traffic and bandwidth patterns from an infrastructure standpoint. This network performance evaluation will reveal which flows are the most congested over time, perhaps posing an issue. Instead of just responding to any performance crisis that may develop, identifying the overcapacity aspects of the infrastructure might lead to preemptive fixes or upgrades that can minimize future downtime. Here are some applications used in the network. While network hardware and infrastructure difficulties can directly impact a specific application's user experience, it's also crucial to consider the impact of applications as essential cogs in the overall network architecture. For example, poorly performing programs can eat up a lot of bandwidth and make the user experience poor. As applications become more complicated, diagnosing and monitoring their performance becomes increasingly important. In addition, application characteristics like window sizes and keep alive have an impact on network speed and capacity. Network issues. The network's intrinsic performance constraints are frequently the focus of attention. Several aspects of the network influence performance, and flaws in any of these areas can lead to systematic issues. Because hardware requirements are so crucial in capacity planning, these components should be built to meet all expected system demands. Network security. Privacy, intellectual property, and data integrity are all protected by network security. As a result, the importance of solid cybersecurity is never in doubt. Device scanning, data encryption, virus prevention, authentication, and intrusion detection are all required for managing and mitigating network security challenges, all of which take valuable network bandwidth and can negatively influence performance. Thank you guys for listening and for watching my video. To summarize, we learned today the measures which uh, from which we can calculate the performance of network. and the causes of latency and the factors affecting to the network. Thank you.